Welcome to Tucson Water's HxGN EAM to GIS integration. My name is Lorena Castañeda. I'm a GIS data analyst with Tucson Water. And presenting with me today is Carla Borbon. She's also a GIS data analyst, and Numesh Menon. On our agenda today, we'll give you a little overview of Tucson Water, our project background, the solution from GeoNexus, our implementation and anticipated benefits, and if time permits, we'll go into a short demo, and then we'll open the floor to questions. With that, I'll hand it over to Carla.
Thank you, Lorena. Good afternoon, everyone. My name is Carla Borbon. Like Lorena mentioned, we're from Tucson, and we work at Tucson Water. The slide that you see here is our Tucson Water service area. Our service area covers over 399 square miles. We were established in 1900. We serve over 775,000 customers. We have 206 active production or standby groundwater wells. We have 60 potable storage facilities capable of storing 305 million gallons of water. We maintain over 4,600 miles of pipeline, and we have hundreds of booster stations and pressure control valves. And with that, I'm going to go ahead and pass it back to Lorena, and she's going to go ahead and discuss a little bit more of the project background.
Thank you, Carla. So in moving to a new asset management, we knew that some of our data was inconsistent and unreliable for decision making. We knew our current asset management software was approaching the end of service, and we had two options. We could either upgrade or replace the software, but we know both required some implementation. So we had two choices. So our change was inevitable for Tucson Water. The HxGN EAM implementation was a citywide adoption, which took 18 months, included 5 city departments with over 1 million assets, 700 end users with both mobile and desktop applications, 115 processes were documented, and there were over 500 meetings and working sessions to get this done. On August 8th of 2022, the city of Tucson went live with the HxGN EAM in the cloud, sunsetting numerous legacy systems and deploying its solution to 700 unique users across 5 city departments, which included water, environmental and general services, business services, management, and procurement. Some of the initial considerations we had with the new EAM was the initial need for GIS integration to the new EAM. Since GIS is a database of record for our linear assets, and we capture data such as main and valve diameter, pipe materials, pipe length, install dates for warranties, and we do asset archiving. So when an asset is taken out of service, we archive it so that work orders aren't written against it. We also had an internal push to get less third-party tools throughout the city of Tucson. So we had to complete a full evaluation of the native integration tool. Some of the integration challenges that we faced were that we had to do a lot of manual processes and checks. From 10 layers that we had in the GIS, we had to break them down by subtype, so we had a total of 37 layers to work with over 20 mappings for each layer. 500 records would take 2 to 4 hours. Some were successful, some were not. Sometimes we'd had to start all over. As our go-live date came closer, we were tasked with getting critical assets synced into the EAM, and after go-live, it took us an additional 4 months to get our records synchronized. With no way to preview before committing, we didn't know exactly how things would look before we pushed them over to the EAM. No reporting led to duplicates, orphans, and errors. One example is that we created 300,000 duplicate service connections because the GIS ID did not come back into the GIS. There's no ability to migrate from one environment to another without having to remap through dev, test, and production, and the tool lives inside of ArcMap, so it makes it tightly coupled to current versions of Esri and HxGN. If you want to upgrade your database, you have to wait for a new version of the tool to come out. In the search for new solution, we previously had a relationship with GeoNexus because we used their GeoSync software with our old EAM, and we knew of a no-code HxGN EAM connector. We had an upcoming deadline, so we were tasked to push all critical assets to the new EAM. And after go live, we were approved to do a pilot of GIP for the integration between GIS and EAM. The project goals for GIP is that we wanted a seamless integration of the GIS and EAM databases to reduce risk, deficiencies, and redundancies. We wanted to maximize the accuracy, integrity, and timeliness of data between the two databases for effective data reporting, analytics, and successful data-driven decision-making. Now Umesh will go over the solution with you.
Good afternoon, everybody. My name is Umesh Menon. I oversee our product development and product roadmaps at GeoNexus. I'm excited to be here this afternoon and with Carla and Lorena to talk to you about this integration story. So just a little bit about GeoNexus. We've been around for about 14 years. We're based in Ann Arbor, Michigan. And we have an integration platform that synchronizes data between EAMs, GIS, and CIS systems. Our customers span mostly primarily North America, but as well as UAE and Australia. We're a HxGN Alliance partner, as well as an Esri Silver partner. So the foundation of our solution is around solving integration needs, where geospatial data is a large component of the organization. Customers typically come our way when they have a custom developed app integration or an EAM component that might be limited in functionality or performance. We take a unique approach to integrations by creating an out-of-the-box platform that's fully supported, easy to use, and also can be maintained for the life cycle and duration of the integration. And we call that product the GeoNexus Integration Platform. So there are three components to our software solution. The first is around simplified configuration. We provide our users with a set of tools to easily configure connections, data sources, and mapping rules. This helps to not only set up the integration, but to maintain it as use cases evolve and new requirements come up. We also provide lots of functionality while you're doing implementation, such as preview mode functionality, which allows you to mimic the synchronization so you can see what it will do without actually committing changes to the system. Really handy when you're doing testing, as well as maybe you're doing a large data load, so you can see before you actually commit those changes, you can see what it's going to do. Second component is around the automated data sync. Once you have your configuration set up, you can set up GIP to run at the frequency that you desire, whether that's daily, weekly, monthly, maybe multiple times a day. When the synchronization kicks off, it's going to extract data, do a full compare of that data, and propagate changes based on the configuration. The third component is around active reporting. This is what our customers really enjoy about our solution. Every time the process runs, you get a report that gives you two levels of information. One is a readout of what happened, what creates, what updates, what deletes did it do, and the second is really around errors and issues. So all the native API error reporting comes back into our reports, and we put that into one report for you to view. And all of this is done through our library of connectors. So we're talking about HxGN EAM and Esri today, but we have others that we support. We also have two generic connectors, one for RDBMS. So you may have like a homegrown solution that doesn't have APIs, so you want to connect to that. It's synchronized data to another system, as well as a generic REST API connector. So if there's a solution that you have that is not pictured here, we might be able to use our REST API connector to connect to it. So our application sits outside of the edge systems we connect to, which makes it a loosely coupled integration. We primarily connect through APIs to the systems that we integrate to HxGN EAM, use the web services connections. To the Esri side, we can connect to the Geo database via Arc objects, or we can use Esri REST APIs to connect to. All of this is handled through our pre-built connectors, so that our users don't have to worry about APIs. It's all configured in the background. Every time you select something, it's accessing calls that the users don't need to worry about. It's happening in the background. So how does this work? When you open the GeoNexus Integration Platform application, you're taking to a user interface. The first time you configure, you're going to establish your edge system connection. So this might be putting in a URL and user ID and password. Once you've done that, you're going to set up your data source alignment. So this could be a feature class on the Esri side, maybe hydrants, and then a data spy on the HxGN EAM side, maybe also called hydrants. And then once you've done that, you're going to set up your mapping rules. And this is really selecting your source mapping fields as well as your target mapping fields. And if you need more advanced functionality, maybe doing calculations, concatenations, translations, that can also be handled through our platform. So just some key benefits to note. One is reducing your burden on IT. So eliminating the custom development and managing everything in one easy place. Not to mention that the application sits outside of the edge system, so if you want to upgrade your systems, you can do that without touching your integration. Realize value quickly through our pre-built connectors and through our user interface. You're configuring and you're getting to production faster. Data validation. Every time the process runs, you get a report of what it did. This is out of the box. There's no configuration needed for that. And then system expertise. It's a fully supported product. So there's continuous innovation that we look at, such as how do we improve usability? How do we improve synchronization aspects? As functionality is improving within GIS and your EAM system, we also need to pay attention to that and improve that functionality. And then also the reporting capability. How do we enhance that? We target quarterly releases for our customers so they can take advantage of the continuous innovations that we put out. We also have a customer support team that can answer questions. We have a customer support portal so our users can come through, and if you're one that likes to figure things out on your own, we have knowledge-based articles so you can be supported in a self-service manner. Thank you. I'll pass it back to Carla.
Thank you, Mesh. So some of the anticipated benefits that we see or we saw with the pilot was it reduced our work. So what we did, you could take like a feature layer and go ahead and create your configuration rules and mappings. And once you were done with that, you could right-click and copy all that into a different feature layer. So that it definitely reduced our work dramatically. We also can copy all mappings and rules and apply it to any instance, whether it be test, train, or production. With create update rules in place, we can easily identify any errors or issues. It is fully supported and easy to use. With the GIP tool, we have reports that are written out in any time the tool syncs. Also, it has preview mode, so you can add any rules or configure it to whatever you want and run it in preview mode to see what it will look like in the end. You can keep it or you can delete it if you want. The GIP tool has value lists, which was extremely helpful. So the 37 layers that we created with the HxGN tool, we were able to go ahead and bring it back to our 10 original feature layers using the value lists. Tucson Water and GeoNexus got together to run a pilot project, and we went ahead and chose 3 data sets. They were the water mains, the gate flow valves, and the butterfly valves. It included creates, updates, and delete rules. We wanted to know if the GIP would meet our needs, and of course it did. Not only did it meet our needs, it exceeded our expectations. Our current implementation tactics was our onboarding approach is using incremental introduction. We had GeoNexus team come to Tucson, Amelia and Shay, to help us. They went ahead and trained us for 3 days. We configured 5 data sets. We went ahead and prioritized more complicated data sets. With the training they provided us, we felt comfortable in configuring the remaining data sets independently. The GIS team will be managing the GIP tool along with the mappings and configuration rules. Both the GIS team and the EAM team will be collaborating with each other to ensure the integrity of the data that is being synced. Some of the future uses that we see is we're in the process of implementing a new CIS billing system in 4 IPS. We would like to use the GIP tool to synchronize address and parcel data and push out addresses from N4 IPS to several services and tables for water, fire, and environmental services. The slide here shows the GIP tool. You can see that a feature class was mapped. It has the configuration rules that are going from, it's syncing between GIS to HxGN on the top, and at the bottom are the configuration rules that are syncing between HxGN and GIS. This next slide shows the summary of the synchronization report. It tells you the feature class that was synced, how long it took, and then on the left, there's like little hyperlink tabs that you can click on and you can see what got created, what got changed, if there were any duplicates, any discrepancies, or any deletes. And with that, I'm going to go ahead and pass it to Lorena, which will
cue the demonstration.
Yes.
All right, TJ, it's coming up.
Sorry.
Good morning. So I'll go ahead and get started. GIP is a true middleware. As you can see, it lives in its own server, which is great. Here we're in the UI for GIP already. And if you can see on the left-hand side, I have my project already created. This one is created strictly for this demonstration. What I'm going to do first is I'm going to go ahead and validate my connections. So I'll expand my connections folder and I'll double click on my HxGN connection. Click validate. I can just close this window and double click my geodatabase connection. Validate. Succeeded. Okay, so GIP has a library of connectors, and if I right click on my connections folder, you can see all of the connectors that are available. I only need the HxGN and the geodatabase connection for now. So next, what I want to do is I want to go ahead and configure my data set. I'm going to expand my folder, and there are 2 ways to create a data set in GIP. You can either right click on data set, start from scratch, or you can right click on an existing data set, copy the data set, rename it, repoint, and just make a few tweaks to the data set. Here I'm going to go ahead and hit cancel because we already have 2 data sets created. We have a linking data set, which is a one-time cleanup to create the GIP ID in both the GIS and HxGN. Then we have our create and updates data set, which will run on a nightly basis and create new assets and make any updates to existing features. So my next step is to configure my data sources. I'll expand my data source folder, and I'm going to right click on my HxGN. This data source tells us that we're creating assets, and we must be pointing to an existing data spy in HxGN. My geodatabase data set, we must connect to the corresponding table of the feature class we are creating. If I pull down the drop-down, you'll see that it contains all the tables that the user has access to. We can create a where clause or a definition query. In our case, we only want Tucson Water owned assets with the life cycle status of active, designed, finalized, and inactive. Once that's done, then what I'm going to do is I'm going to click on the calculated tab down at the bottom. We've created a calculated value for our description field that will be pushed over to HxGN. It's a concatenation of a prefix and some extra attributes from the GIS. Once I'm through with that, I'm going to go ahead and configure my foreign key. I'll go ahead and double click on my water quality sampling create and update dataset. I'm going to click the foreign keys tab. Here I can see that I have my HxGN source and I have my target, which is GIS. And if I do the drop down on the target key, I can see all of the fields that are available to me in the GIS. In this case, I'm creating a GIP ID. Now I'm going to go ahead and click on key generation. And GIP creates a key into the GIS GIP ID field, and a key is also created in HxGN. My key will contain my prefix and will be followed by 7 digits with 0 padding to make a total of 12 characters. I'm going to go ahead and hit save. And I'm ready to create my rules now. So once I expand my synchronization rules folder and my target rules for HxGN, I'll double click on create rules. Here is where we configure our attribute mappings. We have attributes on the GIS side and the HxGN side, and we're pushing from GIS to HxGN. We also have one attribute coming from HxGN to GIS, which is the EAM ID or asset ID. We must also make sure that all of our mappings are included in the data spy that we originally are pointing to in the HxGN data source. So here what I'm going to do is all of the default and the calculated source attribute types are going to be pushed over to HxGN only upon create. Everything else we can go ahead and run on update. So what I'm going to do is I'm going to copy my rules, the rules that I want to be updated on a nightly basis. I'll unselect my default, my calculated, and I'll only keep those field attribute types. I'm going to do the drop down and I'm going to do copy selected. And here I'm going to tell it to move over to my updated rules. Click OK, hit save. If I double click on my updated rules, you see that those are all copied over. Oop, we missed one default. And that's okay because we can check it and just delete it. We can hit save again. Okay, so another component of GIP is that we can create value lists. With value lists, we can push over the correct subtype to the category field in HxGN or the layer field in HxGN. This way we only keep the original 10 layers that we work with in GIS, and we won't have to create 37 layers like we have now. We can also create spatial queries. And we've set those up to identify what work area each asset belongs to. So prior to GIP, we would do this manually. Okay, now I'm ready to run GIP in the console. So I'll double click on my console. And actually before I do that, I want to right click on my water quality sampling creates an update. Right click and I'm going to enable my data set. I'm going to hit save. And one of the many benefits of GIP is that you can run your changes and updates in preview mode, so we don't have to commit. And we can get our eyes on what changes we are really making before we commit to them. Now that I've saved, I'm going to go ahead and hit start. So once connected, GIP will start running. And here you can see the progress of GIP and all of the phases that it goes through. What I love about GIP is that you can see the percentage complete as it's running. So now that the stop button is grayed out, we know that GIP has finished running. So every time that you run GIP, a report is created. So I'm gonna go over to the left-hand side and double click on report. You'll also get a report by email. I'm gonna double click on the very first one. And this report will show you what feature class you are running, how long it took to run, how many features you ran using the GIP. And you don't have to scroll up and down to find, like the table of contents gives you the number of pages. But if you just right click on the tabs over to the left-hand side, it'll automatically take you to where you want to be. This kind of just gives you a breakdown of the different phases as we talked about earlier while it was running. I see like we have an orphan. That orphan was created because we are in preview mode. So once we commit our changes, that orphan will not be there. You can look to see if there were any errors, orphans. If we click on the generated keys tab, we'll see that there was one key generated, my prefix followed by the seven digits. You can see what was created. So from the GIS to HxGN, you can see the different attributes that were being pushed over. Anything that is empty in the values column just means that there wasn't a value in the GIS to be pushed over. And then if I click on my update tab, I can see all of the assets that were updated and what values went over to HxGN. So with GIP, everything is tracked, and you can use these reports for auditing and finding anomalies, orphans, or just what you did in preview mode before you commit your changes. And in a nutshell, that's GIP. Thank you. Good morning. So I'll go ahead and get started. GIP is a true middleware. As you can see, it. Okay, so now we'll open the floor to any questions.
Great job.
Thank you.
All right, I've got a handful of questions, so I'm going to just start from the top and work our way down. Daniel Corson asked, is the data sync performed in real time or at predetermined intervals, for example, hourly or daily?
The sync is ran every night. So IT creates a script that will, it's on a task manager, so it'll run on a nightly basis, and IT creates that script so that you set the time between different scripts that are run for us.
Fantastic. Moving on to the next one. Peter Jerkso asks, how do you manage piping that is running parallel at different depths?
In the GIS, well, we have to, so in the GIS, our assets are larger than life, right? So we have to create separation between them, but we set up dimensions between the pipes to show. We don't really show depth in the GIS, so we whoever is looking at that piece of pipe actually has to go into the document that installed that pipe to be able to find the true depth.
Fantastic. Next up is Annetta Nessel from Greenville Water asked, do you use native ownership field? If so, did you run into any issues? And I can't see the last part, so yeah, we'll go with that.
So native ownership field. I don't know the answer to that question, but I will get with you if you want me to after the session.
It's not my own answer by looking at your mapping. You're using UDS territorial ways for ownership.
Okay, ownership.
Because we actually could use the native field for various reasons.
Okay.
Okay, moving on to the next question. John Clapsaddle asked, can we sync data from a checklist answer?
From a checklist answer, can you give a little more detail on that?
Yeah, so like we do a survey process. So say you took out PVC with the copper, our data require a checklist with the material they installed on the checklist.
So
I
what?
want to keep that in so I get updated just,
Okay, so what the GIS does is once that replacement has taken place, we'll take that work order and we'll update those attributes in the GIS, and then we will resync that. So those are part of our update rules that run on a nightly basis. Yes. And if it's a feature that has been taken out of service, and so if it was a piece of main that was taken out of service and replaced by another piece of main, right, because it's a different material type, then we archive that. We sync, we have delete rules also in GIP. So if it's deleted from the GIS or moved into archive feature class, then it will change it to withdrawn in the EAM. And we will sync the new or create a new ID for the new piece of main.
Would you mind clarifying how the checklist attributes get some of the new assets?
So if we receive a work order in the GIS from in the field, an as-built, any type of document saying that this is what has changed, we will take that existing main out of service in the GIS. We'll move it from our production layer to an archive layer. We'll create a new piece of main and we'll run through the checklist. So we can't do it we can't automate it through a checklist, but the GIS editor will go through and fill out all those attributes to sync over to the EAM.
The lead is you taking the data. So we
Yeah, the GIS team.
That's why I'm thinking through this.
Yeah.
Okay, next question from Peter Jerkso again. Are you using the EAM GIS functionality like map search while looking to look for open work orders?
We have that in one of the layers in the GIS does view active work orders in the system, so the field staff use it on the mobile devices.
So Renee with our EAM team says, yes, we do that.
Okay, cool. Moving on again, John Clapsaddle asked as well, are you preparing for the new ESRI utility network product?
We have started a pilot project on the UN, but with Tucson Water currently, that's on hold, but it is in our future sites. Okay.
Yeah, and just from a platform perspective, we do support the utility network, branch versioning, associations and things like that are all supported through the platform.
That's been our question for our GIS people. We're looking to move, what are they going to be ready if we go to the GIS product?
Yes,
And I really been pushing against that.
that's right. Yeah.
That seems to be the wall I constantly.
Yep, we were actually just having a conversation about that earlier today about what are some paths to get there.
Okay, next up, somebody asked, I see that HxGN EAM is in the cloud. Where are your Esri and GIP software components installed? Are they also in the cloud?
They are not in the cloud. They actually live on servers within our IT.
Fantastic. Lastly, Dora asks, how are you initially capturing your GIS coordinates?
So currently we don't GPS our assets. So we just take those coordinates from the map in the GIS, and those coordinates, they're pushed over to the EAM. As close as can be.
Well, that is all the questions I have in the CVent app. If anybody else has any alibis, going once, going twice. Yes, sir.
It's kind of a two-parter. It was more than I could get in 250 characters. So do you all ever have a scenario, and I'm looking at a very specific use case, okay? So most people are going to be like, man, he should have talked about blah. Do you ever have a scenario where you have to relocate main? So by that I mean you might remove or install a different footage than what you currently have. You take out 100 feet, but you put in 300 feet because you have to go around something. If so, what do you do in those scenarios when all of the downstream attributes are now going to change based upon that? If you're not using GPS, I assume you're using engineering stationing or something like that. We have scenarios in the pipeline business. And that's been a hang up for us because we haven't ever come across anything that could then suddenly switch. And we still have the same GPS locations. We use GPS. But now our engineering series and stationing and some of those attributes have changed for everything downstream. Does it handle that? Will it do that?
So for us, for every asset, let's just say the main was relocated or it was replaced. We will take however many feet of main was replaced and we'll put attribute fittings on each side of the main. We will retire or archive that piece of main and create a new one. So whatever's on each side of those attribute fittings, we'll still keep whatever attributes were there before, and the only thing that will change will be the two attribute fittings connected and the piece of main in between.
We use kind of archaic series stations. What happens is the total footage calculates, and it might be series 100, but then we'll change to series 110, stuff like that. So it's goofy. Thank you. Your question was perfect.
Thank you. Any others? Well, my nerves have calmed down.
Recap, what was the timeline when you were evaluating alternative solutions?
So,
You commented, I think 2 years, you said.
what we have is that the project took place within 18 months, but that didn't include finding a vendor or creating holding sessions. And Jennifer Shivers and her team are here, and she could better answer that question for you.
And then I think the question too for GeoNexus. Did I see in the demo the different kinds of connections you can make? So some were directly to your enterprise geodatabase, some were to ArcGIS Online, so SAS,
Correct.
GIS, and then as well through ArcGIS Server, ArcGIS Enterprise.
Yes, that's right. So we have multiple ways you can connect to Esri. So the geodatabase, if you're using UN, you're going to go through enterprise connection, AGOL. So those are the common ways that we connect. Yeah.
And actually, we have another person that's doing the sync right now that his is a feature service. So he's doing everything with GeoNexus, but with a feature service instead of the database.
And
Feature
curious
class.
about where you're at in your ArcMap to ArcGIS Pro migration. Are you completely moved over to ArcGIS Pro? Or?
We are not.
No.
We are still working in ArcMap. We are not looking at moving to the utility network till maybe 2026, 2027.
Got it. So you're not forced. You can remain on ArcMap for the last
Yes. Short story, yes. Any more? Well, thank you guys for being here today.
Thank you, everybody.